Picture this. You step outside on a clear night, tilt your head back, and stare into the sky. Scientists tell us the universe is overflowing with stars, hundreds of billions of galaxies, each packed with billions of suns. And yet above you, the sky is mostly black, not glowing, not blazing with light, just quiet darkness sprinkled with tiny points of fire. That simple contradiction bothered one of the greatest minds in physics, Richard Feynman. If the universe is so full of stars, why isn't the night sky as bright as the surface of the sun? At first glance, it feels like common sense should win. More stars should mean more light. Every direction you look, your eyes should eventually land on a star. So shouldn't all that light pile up and turn the sky white hot? This puzzle isn't just poetic. It's deeply unsettling. It suggests that something fundamental about the universe is easy to miss, even when we think we understand it. Feynman loved questions like this because they expose the cracks in our intuition. The darkness of the night sky is not a failure of stars to shine. Stars are doing their job just fine. The real issue is distance, time, and the strange way the universe itself behaves. Light, no matter how fast it travels, has limits. It takes time to move across space, and space is unimaginably vast. Many stars are so far away that their light hasn't even reached us yet. We are looking into a universe with a history, not a finished picture. But that's only part of the story. Even if light had enough time, the universe isn't standing still, politely waiting for photons to arrive. Space itself is expanding. As light travels, space stretches, and that stretching steals energy from the light. Bright, energetic light slowly fades, shifting into weaker forms we can't see. What starts as a blaze ends as a whisper. Feynman would point out that the darkness is not empty or meaningless. It is evidence. It tells us the universe had a beginning, that it is changing, and that it is not infinitely old or static. If the universe were eternal and unchanging, the night sky really would be bright everywhere. The darkness is a clue that the cosmos has a past, a story, and a direction. So when you look up and see blackness, you're not seeing nothing. You're seeing the limits of time, the stretch of space, and the deep truth that the universe is still unfolding. The night sky is dark, not because stars are rare, but because the universe is young, vast, and alive. And that quiet darkness above your head is one of the strongest pieces of evidence that our universe had a beginning, and that we are lucky enough to be here while its story is still being written. When we say the universe contains an enormous number of stars and galaxies, we are not using enormous as an exaggeration or a poetic phrase. It is a literal struggle of the human mind to comprehend scale. Every star you see in the night sky belongs to just one galaxy, the Milky Way, and even that single galaxy holds hundreds of billions of stars. Each of those stars is a massive, burning sphere of nuclear fire, many far larger and brighter than our sun. And the Milky Way itself is only one island in a cosmic ocean filled with other galaxies, each carrying its own unimaginable population of stars. As telescopes improved, especially in the last century, astronomers realized that the faint smudges once thought to be clouds of gas were actually entire galaxies, each separated from the others by vast gulfs of space. When we look deep into the universe, we are not seeing a sparse or empty place. We are seeing structure upon structure, galaxies grouped into clusters, clusters forming superclusters, and superclusters arranged along enormous filaments that stretch across billions of light years. Between these filaments lie cosmic voids, not completely empty, but thinly populated, making the universe resemble a gigantic three-dimensional web. What makes this even more astonishing is that stars are not rare or special events. They form naturally wherever gravity can pull gas together strongly enough. Inside galaxies, clouds of hydrogen collapse under their own weight, heat up, ignite nuclear fusion, and suddenly a new star is born. This process has been repeating for billions of years. Some stars live fast and die young, exploding as supernovae and scattering heavy elements into space. Others burn quietly for tens of billions of years. Together they create a constantly evolving population of light sources spread throughout the universe. The numbers quickly escape intuition. Modern estimates suggest there may be more stars in the observable universe than grains of sand on all the beaches of Earth combined. And even that comparison fails, because it still relies on something familiar. In reality, these stars are separated by distances so large that even traveling at the speed of light, It would take years, centuries, or millions of years to move from one to another. The universe is densely populated with stars, yet staggeringly empty at the same time. What we observe is only a fraction of what exists. Our telescopes are limited by distance and time. Light from the farthest galaxies has been traveling toward us for billions of years, meaning we see them not as they are now, but as they were when the universe was young. Beyond that visible horizon, there may be countless more galaxies whose light will never reach us. The universe could be vastly larger than the portion we can observe, filled with stars forever hidden from our view. This realization changes how we think about our place in existence. Earth is not at the center of anything special. Our sun is an ordinary star in an ordinary galaxy, located in no particularly remarkable position. Yet from this small, unimportant corner, we are able to detect and measure the presence of an almost incomprehensible number of stars spread across cosmic time and space. The universe is not a quiet, minimal system. It is overflowing with matter, energy, and light sources, all governed by simple physical laws acting on an immense scale. Understanding that the universe is packed with stars is the foundation of deeper questions. Once you accept how crowded the cosmos truly is, the real mystery begins. Not whether stars exist in abundance, but how their light behaves, how far it travels, and why, despite their overwhelming numbers, the universe still leaves our night sky mostly dark. The night sky appears dark, despite the vast number of stars in the universe. And this simple observation feels almost wrong when you really think about it. If the universe is filled with stars in every direction, then darkness itself becomes a mystery. Every star emits light, and that light travels outward endlessly. So logic seems to suggest that wherever you look in the sky, your line of sight should eventually end on the surface of a star. If that were true, the entire sky should glow with uniform brightness, more like a blazing wall of light than the calm black canvas we actually see. This contradiction has fascinated scientists for centuries because it challenges everyday intuition. When we stand under the night sky, the darkness feels natural and obvious. But from a scientific point of view, it demands an explanation. Darkness is not just the absence of nearby stars. Even regions that appear completely black are pointing toward distant parts of the universe where stars and galaxies still exist. The question is not why some parts of the sky are dark, but why most of it is. One reason this problem is so powerful is that it forces us to think beyond simple counting. It's not enough to say there are many stars. We must also consider how light behaves across immense distances. Light weakens as it spreads out, and stars that are extremely far away contribute only tiny amounts of brightness. Individually, they are too faint for our eyes to detect. Even when billions of such faint sources exist, their combined light does not necessarily build up to brightness unless certain conditions are met. Time plays an equally important role. The universe has not existed forever. There was a beginning, and that beginning limits how far light could have traveled. Many stars and galaxies are so distant that their light simply hasn't had enough time to reach Earth yet. When we look into deep space, we are looking into the past, and eventually we reach a boundary beyond which no light has arrived. Darkness, in this sense, is a record of the universe's age. It marks the edge of what we are able to see. Another critical factor is the expansion of the universe itself. Space is not static, it is stretching. As light travels through expanding space, it loses energy. Bright visible light can be stretched into infrared or radio waves, forms of light that human eyes cannot see. So even when light does reach us from extremely distant stars and galaxies, it may arrive so weakened and transformed that the sky remains visually dark. The universe does not preserve brightness over infinite distances. The darkness of the night sky is also selective. It is not absolute. Sensitive instruments reveal that space is filled with radiation at many wavelengths. What appears dark to our eyes is actually alive with invisible light. Our vision is tuned to a narrow range, and outside that range, the universe is glowing in ways we cannot naturally perceive. Darkness, then, is partly a limitation of human senses. What makes this idea profound is that the dark sky is not a failure of stars to exist or shine. It is evidence that the universe is dynamic, finite in age and governed by physical laws that shape how light moves and changes. If the universe were eternal, static, and unchanging, the night sky would not be dark at all. It would be uniformly bright, with no shadows, no contrast, and no night as we know it. So when we look up and see darkness, we are not seeing emptiness, we are seeing distance, time, expansion, and the limits of perception all at once. The dark sky is a silent message written across the universe, telling us that even in a cosmos overflowing with stars, darkness can exist, and that its existence reveals deep truths about the nature and history of the universe itself. Light from distant stars takes time to reach Earth, and this single fact quietly reshapes how we understand the universe. When we look up at the night sky, it feels like we are seeing the universe as it exists right now, in the present moment. In reality, we are always looking into the past. Every beam of light carries with it a history, a record of where it came from and how long it has been traveling through space before finally reaching our eyes. Light moves incredibly fast, faster than anything else in the universe, yet the distances between stars and galaxies are so vast that even this extreme speed becomes slow. Light from the sun takes about 8 minutes to reach Earth, which means if the sun were to suddenly vanish, we would not know it for 8 full minutes. The nearest star beyond the sun is so far away that its light takes more than 4 years to arrive. When we see that star in the sky, we are not seeing it as it is today, but as it was 4 years ago. As distances increase, this time delay becomes enormous. Light from nearby galaxies can take hundreds of thousands or millions of years to reach us. Light from the most distant galaxies we can observe has been traveling for billions of years. That means when astronomers look deep into space, they are seeing galaxies as they existed when the universe was young. Some of the stars whose light is reaching us right now may no longer exist at all. They may have burned out, collapsed, or exploded long ago, yet their final light is still on its journey. This delay creates a natural limit to what we can observe. The universe is about 13.8 billion years old, which means light has had only that much time to travel. No matter how powerful our telescopes become, we cannot see beyond the distance light has been able to cross since the beginning of the universe. There are regions of space so far away that their light has not reached Earth yet, and it never will. These regions exist, filled with stars and galaxies, but for us they remain forever invisible. This idea explains why the night sky is not overwhelmed by light. Even though stars fill the universe, we do not receive light from all of them. We only see the stars whose light has had enough time to arrive. Darkness is not evidence of emptiness, it is evidence of unfinished travel. The universe is not fully illuminated because the universe itself has a limited age. The time travel aspect of light also means the universe is a layered story. Nearby objects show us recent events, while distant objects reveal ancient ones. The farther we look, the younger the universe appears. In this way, space becomes a time machine. Astronomers do not need to guess how the early universe looked. They can observe it directly by studying light that has been traveling since near the beginning of time. This realization changes the meaning of observation itself. Seeing is no longer a passive act. To see something in space is to receive a message sent long ago, one that has survived collisions, gravity, and cosmic expansion. Every photon that reaches Earth has completed an extraordinary journey across an expanding universe. So when you look at the stars, you are not just looking across space, but across time. You are witnessing ancient light finally arriving, connecting the present moment on Earth to events that happened millions or billions of years ago. The night sky becomes a living archive, and its darkness marks the places where light is still on the way. The universe is not infinitely old, and this fact quietly explains many of the mysteries we see when we look into the sky. It is easy to imagine the universe as something that has always existed, stretching endlessly into the past with no beginning. For a long time, many people believed exactly that. But modern science shows us a very different picture. The universe has a definite age, and that age shapes everything we observe, including the darkness of the night sky. The idea that the universe had a beginning means there was a moment when stars, galaxies, and even space itself did not yet exist. Before that moment, There was no light traveling through space because there were no sources of light and no space for it to move through. As the universe expanded and cooled, matter began to form, and only much later did the first stars ignite. This delay matters. Even in a young universe, darkness was the natural state long before the first stars ever shone. Once stars began to form, their light did not instantly fill the universe. Light takes time to travel, and the universe's age limits how far that light could have gone. Because the universe is only about 13.8 billion years old, there's a maximum distance light could have traveled since the beginning. Beyond that distance lies a boundary not of space, but of time. Stars may exist beyond it, but their light has not had enough time to reach us. If the universe were infinitely old, the situation would be completely different. In an eternal universe, light from stars would have had unlimited time to travel. Over endless ages, light from every direction would accumulate, and the sky would glow uniformly bright. There would be no true night, no deep darkness between stars. The very existence of a dark sky tells us that the universe cannot be infinitely old. Darkness becomes evidence of a cosmic beginning. The finite age of the universe also means that what we see is incomplete. We are observing a universe in progress, not a finished product. Galaxies are still forming, stars are still being born and dying, and light is still spreading outward. The universe has not had enough time to fully illuminate itself. Darkness, then, is not a flaw or a mystery to be eliminated, but a natural consequence of a universe that started at a specific moment in time. This idea also changes how we think about time itself. The universe does not simply exist within time. Time is part of the universe. When the universe began, time began with it. That means asking what happened before the universe may not even make sense, because there was no before in the way we understand it. The age of the universe sets the ultimate clock that governs everything we can observe. Understanding that the universe is not infinitely old gives meaning to cosmic history. The light reaching us from distant galaxies is a record of earlier eras, showing us how the universe looked when it was younger and simpler. The darkness beyond what we can see marks the edge of that history where light has not yet arrived. So when we stand under a dark night sky, we are witnessing the youth of the universe written in blackness. The darkness is not empty or meaningless. It is a sign that the universe had a beginning, that it is still evolving, and that we exist at a moment when its light has not yet had time to reach everywhere. Space is expanding, and this single fact changes the way light behaves as it travels across the universe. The expansion of space does not mean that galaxies are flying through space away from one another like shrapnel from an explosion. Instead, it means that the space between galaxies is stretching. As the universe grows, the distances between objects increase. Even if those objects themselves are not moving much within their local regions, when light is emitted from a star or galaxy, it begins its journey through this expanding space. At the moment of emission, the light has a certain energy and wavelength. But as it travels, the space it moves through slowly stretches, and that stretching also stretches the light itself. The wavelength becomes longer, and the energy of the light decreases. This process is known as redshift, and it plays a crucial role in why the universe does not appear overwhelmingly bright. Bright, visible light can be stretched into infrared, microwave, or even radio wavelengths. Human eyes are sensitive to only a narrow band of light, so when light is shifted outside that range, it becomes invisible to us. A star or galaxy may still be emitting enormous amounts of energy, but by the time that energy reaches Earth, it see and be diluted and transformed into a form we cannot see. The sky remains dark, not because light is absent, but because much of it has been stretched beyond visibility. Expansion also spreads light out over increasing distances. As space grows, the same amount of light is distributed across a larger volume. This further reduces brightness. Even if countless stars are shining, their light does not stack up in one place. It thins out, becoming fainter as the universe expands. This prevents the sky from filling with intense uniform light. The expanding universe also tells us something profound about cosmic history. The fact that space is stretching means it was once smaller and denser. In the distant past, galaxies were closer together, and light traveled through a much more compact universe. As time passed, expansion increased distances and weakened the light traveling between them. The darkness we see today is partly a result of billions of years of cosmic stretching. This idea is supported by observation. Astronomers see that distant galaxies are more strongly redshifted than nearby ones. The farther away a galaxy is, the more its light has been stretched, and the faster it appears to be receding. This pattern shows that expansion is not just a theory, but an ongoing process that shapes everything we observe. Expansion also means the universe has a future that will look very different from its past. As space continues to stretch, light from distant galaxies will become even more redshifted and harder to detect. Over vast spans of time, many galaxies will fade from view entirely, leaving future observers in a darker, quieter universe. Darkness is not only a feature of the present universe, but a preview of what is to come. So when we see a dark sky, we are witnessing the effects of an expanding cosmos. Light is being stretched, thinned, and transformed as it travels across growing distances. The darkness is not a sign of emptiness or failure, but a natural outcome of a universe that is dynamic, evolving, and constantly expanding in all directions. The darkness of the sky is evidence of the universe's evolution, not a simple absence of light, and this idea transforms darkness into a powerful scientific clue. At first glance, the night sky seems empty and still, as if nothing is happening beyond the small points of light we call stars. But that darkness is not silence or inactivity. It is a record of how the universe has changed over time and how it continues to change even now. If the universe were static and unchanging, the sky would look completely different. In a universe that had always existed in the same state, light from stars would have had infinite time to travel. Over endless ages, that light would accumulate from every direction, filling all of space with brightness. There would be no deep darkness, no black gaps between stars. The fact that we see darkness at all tells us the universe is not eternal in a steady form. It has a history. That history includes a beginning, a period of growth, and ongoing transformation. After the universe began, it expanded and cooled, allowing matter to form. Stars and galaxies did not appear instantly, they emerged gradually. The darkness we see is partly a snapshot of that process still unfolding. The universe has not had enough time to light up every corner, and some regions remain beyond our observational reach. Darkness also reflects change in the behavior of light itself. As the universe evolves, space expands, stretching light and reducing its energy. Light that once blazed brightly becomes faint or invisible by the time it reaches us. This fading is not random. It follows precise physical laws that tell us how the universe grows. The dark sky preserves the evidence of that growth. Even the background darkness is meaningful. Sensitive instruments reveal faint radiation filling space, leftovers from the early universe. This radiation is weak and invisible to human eyes, but it shows that the universe was once hotter and denser. The darkness we perceive is layered on top of this ancient glow, hiding a deep cosmic memory beneath what appears to be emptiness. The evolving universe also means that what we see now will not always be the same. In the distant future, continued expansion will push galaxies farther apart. Their light will stretch so much that it will fade beyond detectability. Future observers may see a darker universe than we do today, with fewer visible galaxies. Darkness, then, is not fixed. It changes as the universe changes. This perspective turns the night sky into a kind of historical document. Every dark region marks a limit, either of time, distance, or energy. It tells us where light has not yet arrived, where it has faded away, or where the universe has stretched beyond our ability to see. The darkness is not empty. It is structured by the universe's past and shaped by its future. So when we look into the dark sky, we are not looking at nothing. We are looking at the universe revealing its story in reverse, using absence as evidence. The darkness confirms that the universe is dynamic, finite in age, and constantly evolving. It is proof that the cosmos is not frozen in time, but alive with change, and that even what we cannot see carries meaning about how the universe became what it is today.